Hello friends, today I'm going to give you a brief lecture about addition and subtraction of vectors. Let's start from addition of vectors. There are two main rules, triangle rule and parallelogram rule. Before I start explaining the triangle rule, let's remember that this point of vector is the beginning of the vector or beginning point of the vector, and this one is the ending point of the vector. And for this one is the same. This is the beginning point of the vector and this is the ending point of the vector. Now we can see that we have two vectors, vector A and vector B, and we need to find the sum of these two vectors, which we call C vector. To add these two vectors, first what we need to do is to connect them. So basically all we need to do is to connect the ending point of one vector to the beginning point of another vector. So for that we need to move the one vector to another vector. And when you move vector, you can move it only parallel to its previous position. So let's see. I'm going to move vector A to vector B. As you can notice, this vector is parallel to its previous position. You see? So remember, when you move a vector, you should always move it parallel to its previous position. Now that we connected two vectors, let's find the sum of these two vectors. And it will be vector C. To understand why this vector is pointing to this direction, not to this direction, let's remember one thing. So I'm going to explain you in more easier way so you can easily understand how to add vectors. Imagine that you're going on a journey and beginning point of this vector is the beginning of our journey. And then you moved to somewhere this direction, and then you move to somewhere to another direction and you arrive to this place. And this is the ending point of your journey, end of your journey. So all we need to do is to connect the beginning of your journey to the end of your journey. So the arrow should be pointing to the end of your journey. That's how you do addition of vectors. When we do addition of vectors, it doesn't really matter. It is vector A plus vector B or vector B plus vector A. The resulting vector will be anyway the same. So let me show you. We can move vector B to the down, parallel to its previous position, and we can move vector A to the right side, also parallel to its previous position. So now what we can see, this is the beginning point of our journey. Then we moved here, and then we moved here, and all we need to do is to connect the beginning of our journey to the end of our journey. So as you can see, this vector is still remains the same. Now let's talk about parallelogram rule. In parallelogram rule, if we want to sum these two vectors, we need to connect the beginning points of two vectors. As you remember, in triangle rule, we connected end point of one vector to the beginning point of another vector. But in this case, we connect the beginning points of two vectors, like this. And now all we need to do is to draw parallelogram, like this. And the sum of these two vectors will be this vector, vector C. As you can notice, the beginning of this vector C is the same as the beginning points of vector B and of vector A and vector B. So you can use either triangle rule or parallelogram rule. The result will be the same. So it is all about convenience which rule to use, this one or this one. In some cases, this rule is more convenient to use, and in some cases, this rule is more convenient to use. For example, if there are many vectors, then the triangle rule is more easier to use. For example, this triangle rule you can use not only for two vectors, but you can use for addition of many vectors, like 2, 3, 4, 5, 6, doesn't really matter. So for example, we have 3 vectors, A, B, and D, and we want to find the addition of these 3 vectors. So all we need to do is to connect ending point of one vector to the beginning point of another vector, like this, and then we will connect end point of this vector to the beginning of this vector, like this. And the sum vector, let's call it C, will be this. So we did the same thing as we did here. We connected the beginning of our journey to the end of our journey. So this is the main rules for adding vectors. Now let's talk about subtraction of vectors. So we have vector A and we have vector B, and we need to find A vector minus B vector. As you remember in the previous slide, when we used triangle rule for addition, we connected the ending point of one vector to the beginning point of another vector. But in case of subtraction, we need to connect the beginning point of one vector to the beginning point of another vector, like this. Then resulting vector C will be like this. You may have a question why this vector has this direction. So you need to remember that the direction of resulting vector will be towards the vector from which we subtract. Since we subtract from vector A, the resulting vector is pointing towards the vector A. And if we want to find vector B minus vector A, then it will be opposite, because in this case we subtract from vector B, so the resulting vector is pointing towards the vector B. Also, as you can notice, these vectors are different. This vector is C and this vector is E. As you remember in the previous slide, vector A plus vector B was equal C, and vector B plus vector A was also equal C, so it didn't really matter. But in this case it matters, because in this case the resulting vector changes its direction, and when the direction is changed, it's already a different vector, because the vector defines by 2 parameters. It's a direction of vector and the length of vector. So even though they have the same length, but they have different directions, so these vectors are already different. Now let's talk about parallelogram rule for subtraction. It's basically quite similar with triangle rule. So for example, we have vector A and we have a vector B, and this vector is the sum of these 2 vectors, and the subtraction will be this vector. Also, as you can notice, the direction of vector C is towards the end point of vector A, because we subtract from vector A. And if we want to find vector B minus vector A, then the resulting vector will be pointing toward the vector B, since we subtract from vector B. Now let me show you some interesting examples. For example, we have vector A and vector B, and we want to find A vector plus B vector. So as you remember, all we need to do is to connect the ending point of one vector to the beginning point of another vector. And after that, we need to connect the beginning of our journey to the end of our journey. So the resulting vector C will be like this. Now let's look at the second example. We have vector A and we have vector B. But in this case, vector B has the opposite direction to vector A. In this case, it was the same direction, but in this case, it is opposite to the vector A. So how can we find vector C in this case? So let's do the same thing as we did in here. We will connect the ending point of one vector to the beginning point of another vector. So it will look like this. I haven't exactly connected the ending point of one vector to the beginning point of another vector, because they will overlap each other and you cannot see clearly. So that's why I left some space here. And all we need to do now is to connect the beginning of our journey to the end of our journey. So the vector C will be like this. Now let's look at the third example. So we have vector A and vector B, and they have the same direction, But in this case, we need to find A vector minus B vector. So as you remember, for subtraction, we need to connect the beginning points of two vectors. So that's what we are going to do here. And the resulting vector will be pointing towards the vector from which we subtract, like this. And if we want to find B vector minus A vector, then the resulting vectors will be opposite. Now let's look at the fourth example. We have two vectors, vector A and vector B, and they have a same length but opposite direction. Since these two vectors have a same length but different direction, we can write that vector B is equal minus vector A. And if we put minus A here instead of B, we will get A vector minus A vector. So it will be just 0. Now let's look at the fifth example. We have a vector A, and we need to find 3 multiplied by vector A. So what it will be? It is easy. All we need to do is to multiply the length of this vector by 3. So you can notice that this vector has length of 2 squares. So when we multiply by 3, it will be the length of 6 squares. So this is the resulting vector. Now let's look at the sixth example. We have vector A, which has the length of 6 squares, and we need to find minus A vector divided by 3. First of all, since it's minus, we need to change the direction of vector A, and then divide it by 3. So this will be the resulting vector. It has a 3 times less length than this vector, and the direction is opposite to the vector A. That's all for today. Thank you for watching. Subscribe for more math videos.